Determine the eccentricity and then identify the type of conic section given the polar form of the equation. To do this, we need to write the equations in one of the forms shown here on the right. Focusing on the denominators, notice we need the denominator to be in the form of 1 plus or minus e cosine theta, or 1 plus or minus e sine theta. Once we have the denominator in this form, e is the eccentricity, which we can use to determine the type of conic. If the eccentricity is between 0 and 1, we have an ellipse. If the eccentricity equals 1, we have a parabola. If the eccentricity is greater than 1, we have a hyperbola. Looking at the first polar equation, we need the 2 in the denominator to be a 1 to determine the eccentricity. This indicates we can either multiply the numerator and denominator by 1/2 or divide the numerator and denominator by 2. I'm going to go ahead and multiply the numerator and denominator by 1/2, which gives us r equals 1/2 times 8, all divided by 1/2 times the difference of 2 and sine theta. Multiplying 1/2 times 8 is 4. We have 4 divided by, distributing 1/2, 1/2 times 2 is 1, and then minus 1/2 sine theta. Now that we have the polar equation in the correct form, notice the eccentricity E is equal to 1/2. Because the eccentricity equals 1/2, we know the graph of the polar equation is an ellipse. And it's also true that one focus will be at the pole. Let's verify this graphically. Here we have the graph of the polar equation, which we should recognize as an ellipse, and one focus is at the pole. Let's look at our second example. Again, focusing on the denominator, we need this 4 to be a 1 to identify the eccentricity, and therefore we'll multiply the numerator and denominator by 1/4. This will give us an equivalent equation in the correct form, which gives us r equals 1/4 times 9, all divided by 1/4 times the sum of 4 and 10 cosine theta. Multiplying, we have 1/4 times 9, which is 9/4, divided by 1/4 times 4 is 1, plus 1/4 times 10 cosine theta is 10/4 cosine theta, which simplifies to 5/2 cosine theta. Now that we have the denominator in the form of 1 plus 5/2 cosine theta, we know that the eccentricity equals 5/2, which is equal to 2.5, which is greater than 1, indicating the conic section is a hyperbola. Again, let's verify this graphically. Here's the graph of the second polar equation, which we should recognize as a hyperbola, and one focus is at the pole, this point here. I hope you found this helpful.